In this instructional video we'll look at a slightly different deposit. So this is the Fruta del Norte the deposit, for who's familiar with it. It's a deposit that's been constrained by two major faults running through it, and we'll just highlight some of the tools that we can use on modeling these faults, but also how you treat the data to then use the volumetric modeling as part of it. So what I've shown here, or what I'm showing here, is the topography at the top as a surface. Won't go into that too much for now, but just as a reference, it's there. Then we have a few major units. So we have the purple one at the bottom, that's the underside. We have the green one, which is the conglomerate. We got some unknown or no data parts here where it's not logged properly. But then up here we have the post-conglomerate andesite, and there's a little bit at the top here, which is a sandstone cover. What we would typically do is actually model this from the youngest unit here, the sandstone cover, through to the bottom, to the oldest units. But as you can probably see in the side view here, the andesite and conglomerate have these faults running through them. So you can clearly see some offsets in the data there. Whereas the upper units, the sandstone cover, the post-conglomerate andesite, have not been affected by these faults. So we can't use the typical approach that we would normally do. But we'll go through it, and then hopefully it will be clear at the end. So we'll start with the sandstone cover here at the top, and we'll just model it roughly as a sedimentary unit, so just as a single layer there. So like others, what we need to do, we take the lithology data, convert that into interval or indicator points. So here we have lithology, and we'll do the sandstone cover here. So the sandstone cover is at the top, but it needs to generate points compared to everything else. I'll just scale this down a little bit to maybe 1 meter, because it's very thin. Let's just see how thin it is. So just take it that way, and then we use our classification function. So we'll just say send. Let's go our function. I'll just leave everything at the defaults for now, and then we'll run this one. So now you can see that it's converting the intervals to indicators, and then when that's done, it shall show, and there we go, we have something trying to model the sandstone cover. So it's okay. It's going up a little bit. It's a little bit dented here. Let me just see if a different function will improve the situation a bit. So now we've used a different classification function, but as you can see, it's started to curve in on itself way too much for my liking. So it's not as important, so I'll stick with this one, but I'll increase the range a bit, and we'll run it again. Okay, that's finished. I'm pausing the video in between, so it just appears as everything's finished. Now this is a little bit better. We just could tweak it more probably with changing the sampling rates, but this is okay for now. So we can play with these things a little bit to find the right sort of shape for it. Okay, so we've got the sandstone cover. So then there's a bit of conglomerate here sitting just below it, but then we have post-conglomerate andesite inside the conglomerate. So what we need to do now is to actually model this post-conglomerate andesite, because it's a newer unit than the conglomerate itself. So we model that one first, and then we do conglomerate later on. So let me just hide sandstone function here. go back to our processing, and then we could just switch this one to the post-conglomerate andesite we want to model. In this case, we want to turn off the sandstone cover because we've already modeled that one. We don't need to take that into account anymore. And I'll just really increase the sample size a bit. Should make it a little bit quicker. I'll leave it at 2 meters. I'll leave this as it is. Okay, and we'll just rerun this one. I'll just pause the video again. So we've done the first 2 layers here, or the first 2 units, modeled them independently. So now we would typically go on to model the conglomerate, but as you can see, this is heavily faulted. So what we need to do now is actually model those faults first. Different ways of modeling faults, and it really depends on the data and what you have available. So let me start with the easiest one, which is on the east side here, where there's an offset and we only have 3 drill holes to the left of it. We could set up the section plate. So what I can do here is actually take the section plate. So what I've done is to remove the front in this case, so I can see only the back, and I can move this plane around a little bit. So turn on the section controls. We can change the setting a little bit. We could roughly get an idea of the orientation. So we're using the section plane here actually as a modeling tool as well, so we can put it in place. Right now it's dipping more or less 90 degrees down, so let's put it really at 90 degrees. So now we have a really vertical fault, which might not always be realistic, but in this case I think it's good enough. So we set it up here where we have this offset between 2 units. Let me just change it a little bit. There we go. Right. So when we have this aligned, and you can tweak it more for yourself if you want to, we can actually convert this section plane into a surface that you can use for further modeling. So east fault, let's call it plane. Just press OK. That's it. We have our first fault plane running through. On the western side there's also fault running through. As you can see, there's a sort of like the horizontal section in the middle here, the central section, and then there's this drop off to the western side. So I've modeled this before, and I'll demonstrate what I've done here. So try to make this fault just running through some of the drill holes and then cutting through at an angle, and later on we'll see how we use that in our modeling then. But the first step in this one, as you can see, it's not a single straight surface that you can use, is to actually draw this inferred fault. So that's why we put the topography back on. I'll remove the eastern fault. So we take the topography and try to get a clear sense of where this fault is located in space. And so we have these draws on the right here that need to be separated from the ones in the central on the left from that angle. So for this I've actually used the drawing tool. I'll demo west fault. Now we can choose to draw on the section plane, which is the default, but in this case you want to draw on the topography. That's why I've set a transparency on the topography to sort of see through and allows me to also visualize the drill holes that way. We have all these ones to exclude here, and then here we have the ones we want to include. In the modeling, I'll just reset that one because I accidentally was drawing on topography there. So we'll start roughly here, and at the moment I'm just using simple clicks to say, okay, this is roughly where it needs to be. So we could, sorry, that's completely off, isn't it? So I need to move this one here, move that one there. Probably move these ones up here a little bit. So we have a better view, roughly where it needs to be, although there's a few here that I want to show. So I think these ones here tend to be above and they need to be extruded, so I think this one needs to go right in the middle of these ones here. Move this lower. As you can see, I'm just using these simple straight lines. You can make more advanced Bezier curves, but I'll make that a separate video. Just want to focus on modeling this for now. So let's turn this one around. See if that's to be included. So here you have these ones to include as well. All right. Let's see. I think it should be fairly okay. So we have this line, so we can modify it if we need to. So we save this one. Now we have a polyline on the topography. What we can do in the processing, so we remove this by clearing it. We take this, and then we go to surface-based modeling to create a surface from this by extruding the polyline that we have to create a fault surface. So we call this a west fault surf. I want to extrude it, well, definitely more than 50 meters, so about 500 meters, so we want to have the plunge angle and azimuth. So let's take roughly the view that we have here, so minus 64, azimuth of about 90, minus 64, and this 90, press OK and press run. Okay, so now we have a surface that's running through it. Alright, so you can see now that there's a few drill holes that have been included on the wrong side of that surface, so we could maybe change that a little bit. We could edit the polyline as well, so if we can go to this one, or we can go to the edit mode, and we can move points. So that's a slight weird thing that it actually produces some additional points, so you might have to remove some first before you move the final point. By pressing the backspace key you can actually delete points. Alright, so let's put it there. Okay, so although we have set it up, we need to reattach this one and run the model again. So now we have a new surface. Let's see what, okay, I've made a mistake here by editing not on the surface but actually editing on section plane. Right, so we need to go back to this one, and that's why we need to set this one to a topo surface where we want to edit it, and we need to reattach this one. Okay, so here, and this one here as well. Let's see if it's now on the surface. Yes, it is. So we save this one, do the same process again, and touch the newly created one, and let's see how that looks. That's a lot better. So we can remove this one completely. Alright, still there's a bit of the central lines in there. Probably if we make it a bit smaller, it's not as bad. Probably if we increase this to be a little steeper, might actually improve it. Yeah, it seems to be alright now, so I'll just remove this one. Now we could use this for the modeling. Alright, so what we've done now is to model this fault We have the east fault here. So we've now modeled the two faults, the main faults running through, and the last bit I've created this fault, but I'll use one that I've created earlier as a bit of a demo because it's extending a little bit further. It's actually a bit easier to use. No, that's not the one I want to turn on, so I want to have the east fault. So you can see these cutting through, and we'll need these ones to create separate domains and for our final modeling. But what we also need to do is to create separate functions for the underside. So roughly, let's say the boundary between the underside and the conglomerate. Because of the faults, you can't use all the data. You could, but then you get a very curvy surface, which is not what we want in this case. We want to have a quite clear distinction between the central zone, the west and the east. So we need to extract the volume points that represent the points on the west side and also for the central side. I'll just demonstrate it for the west side, and I'll show you what I've done for the east beforehand. So for this, we actually do selection of the drill holes that we want to use. For this, we go to this one here. So we select the data set where we want to create our selection, which is the lithology data. We press OK. As you can see, I've already made some selections beforehand. I'll just repeat that one for the west. Demo west. Okay. So now we've created our selection. We can start adding segments into this selection that we want to use. So we turn on this selection, and okay, let's hide all, and show this one. I'll just make it a bit bigger. There we go. You can see what I've selected here. So turn off the. So here you see that these ones are included in the selection, but I haven't included this one here. So what we can do is turn this back on. Probably this one. Want to have everything in there. So while I'm on the 3D, I can press the space bar to toggle the selection mode on and off. As you can see, I don't really want to include these ones as being inside points because we just want to have all the ones on the west side of the fault. So I'll just remove this by subtracting the selection and then turning on the selection, saying okay, this one needs to go and that one needs to go, and then I can add new parts to it. So here you can see that this one needs to be added here as well. And you see that you can already do selection on just part of the trays that you want to include. Alright, there's another one here that hasn't been included yet, so we'll just that one as well. I think that's probably all the ones that I wanted to use. Could probably include this one here at this end as well. Say, oops, it's probably okay. Yep. So we have selected the intervals that are considered to be on the west side of that fault. Alright, so now we can actually extract volume points just for this selection part. So instead of what we've done before, where you do, so we'll go to volumetric modeling, convert intervals to indicators. Instead of what we do normally, where we say, oh, you want to extract the underside and you get all of them, we actually turn this on to use the manually selected segments. So I've just created this demo west, so that's the one I'll use for now. I'll leave this as 5 meters, which is fine. It's just for showing what is going to happen. Run this one and we'll turn off this one. So now, as you can see, we have inside points for all the intervals that we selected, and for those drill holes it also creates the outside point. So not for all the other drill traces that we haven't created any selections on, just for these ones. And then we can use that one to create a function. So what we would do again is just to create this ML function. I'll just call this demo again. Demo and the side west indicators. So leave everything at the defaults just to see what sort of function we get. And now we have it. We have a function representing the underside west of that fault surface that we have. So where's our fault surface that we've created? Okay, so yeah. The thing to keep in mind, because you're creating these functions, they are unconstrained. So we show them constrained by this model boundary, but typically the function would just continue and go off in one way or another. So we only have to keep in mind that for our final modeling, we'll just be using the function on the west side of the fault here. So whatever is on this side of the fault is actually irrelevant. So the shape and everything that happens on that side of the fault is irrelevant for our further modeling. So we've done the same thing for the central side. Let me see where I have points here. Right, so I've actually called that test. Probably not the best name to give it, but we can use those ones to create a function for that. So we call this underside our demo underside central. Same settings, indicators, everything. Run this one as well. So here we have a function representing the central zone of the underside. If we compare these two, where's that? So we have the surface for the west side and a surface, or it's not a surface, but a function for the west side and a function representing the central unit. Alright, so now we have all the building blocks for building the complete model that we want to build. So let's get on to the exciting bit, and using all this information that we've created. So we just, well, let's keep that one because we're still gonna need that. So we have the functions for that one. Let's see if I have all the other ones. Now we have the send topo function. So I've created a function for the topography earlier on. So we just need functions for the faults, which I see we haven't created yet. So I'll just use that one that I had, and the east fault I can actually use. Alright, so for the faults, because we've represented them as surfaces, we can actually take a bit of a shortcut on creating functions for them. So for this, I'll take the west fault, and instead of using our machine learning classifying function, we can actually use something that we call sign distance classification function. So if we take this one, for example, we can show positive and a negative side, so the red and blue sides. So we see that the positive side is on the left. We'll need to keep that in mind later on for the actual modeling. We can create a sign distance function here, so we call this west fault signed function. Okay, should be fairly quick. So now you see that it's overlapping. Don't worry about the shape above this. This is sort of a artifact of extrapolation because there's no surface there anymore. And we'll do same for the east fault plane. So we create a sign distance for that one as well. Let's call that one the east fault sign function. function there, so we can turn these off. Now we have functions for all the different units, or all the different domains that we want to model. So the modeling of the final output is going to be done again through descriptors. Let me just turn off the functions for now, and I'll just start with the topo function. It's actually turned on, and we still have set cover function turned on. Okay, so we have a function for the topography, and that's probably the first thing that we want to do. So we need to create a new model. So we call this let's call this scenario 1 or model 1. I like to call them scenarios because we can have different scenarios, especially in complicated situations where you're not quite sure which unit to model first, so you can compare them. But the first thing that we typically want to do is add topography here. So everything above the topography, don't want to call it topo, but we want to call it air. So if we take this one, just run this one. Okay, let's do that one. So this is just to get an idea of what's going on. So it's actually creating a tetrahedral model and optimizing it now. So we should see something. Yep, it's been cut off by the topography. So we have what we have here is the wrong side of what we wanted to model. So we have unknown at the top, but it should be unknown at the bottom, and above should be air. So we cancel this, remove this one. So now that's just to do with the sine distance function from surfaces. So we remove this one, and we'll add a topography function here, but actually set it to the other side, and that should be called air. So now we know that we have that one sorted. So if you remember, we looked at the lithology here, and then we had the sandstone cover at the top, so we want to add that into a model. So we go to the sandstone cover, so we can call it sand, but don't like that too much. So lithology, and then we go with sandstone cover. Okie dokie. And the next one then was the post-conglomerate andesite. So take that one into consideration. So it has already updated the name correctly this time. Now I'll stop here and just model this for now. Alright, so we run this one and go. Alright, I've just paused the video with processing. It doesn't take too long, but it's a bit boring to wait for it. So now you can see that we have some units protruding through here already. So let's see what we have now. So let's turn off the unknown, and let's turn off air, and let's also turn off, why is these ones turned off? Okay, so now we have a little bit of sandstone cover here, which is the bluish one in this case, and then we have the post-conglomerate andesite sitting inside the conglomerate. But as you've probably noticed earlier on, just one thing, you can also see that the post-conglomerate andesite and the sandstone cover actually clipped against the topography this way, because we use the topography first to limit the extent of the model. But what I was going to say, if you notice what we've been doing before is actually modeling the andesite and not so much the conglomerate. We could have done it both ways and just modeled the conglomerate against the andesite, but since we've been using the selections, I thought it easier to do the selections on the andesite, and it's actually the andesite itself that's been folded, and the conglomerate is just placed on top of that. So it was a bit easier to do it that way. So we don't have a function to define the conglomerate in this case. So the next thing that we need to do is actually model the andesite and everything that's left over is then called conglomerate. But since we have these faults running through, we can't just take a single function and model it that way. So we need to create separate domains first and then subdomain them. And that's what we're going to do in the next little bit. So let me just turn this off because we're not interested so much in this anymore. And let me just go back to what we've shown before. So we have this east fault, and I think I've used this one here. So this is already been turned on to sort of like indicator color. We'll do the same thing there. So we see that the east of the east fault is sort of the positive side of the east fault, and the eastern side of the west fault is also the positive side. And that's important to know, because this means that in our modeling here we need to specify the correct side, the correct polarity, if you want to call it that. So what we need to do now, I'll start from the west fault and build it up that way. So let's see, this is the west fault sine function. Alright, so I want to model everything towards the west of this fault. So in this case, because of the polarity, it needs to be on the blue side of that surface that I just shown. So this is smaller than, and I'll just call this west zone maybe, or whatever you want to call it. So this is just a temporary placeholder for further modeling later on. So we create this west zone. So it means that everything towards the east is going to be labeled unknown. So what we're going to do now is to then separate the remaining part. Well, let's just build this one first, and then you'll see what I mean. Right, so we'll rebuild this one, and I'll pause it a little bit until it's done with processing. Alright, that's just finished. That's not too bad. So here you can already start to see what's happened. If I go to so we see that this unknown zone, or the unknown area, is towards the east of the west fault. So everything on the western side of that fault is called west zone now. So I can model this west zone separately, and for that I need my function on this western side. So let's see what it looks like. So here we have andesite below and conglomerate on top within the west zone. So there's flexibility here, so I could do it in different ways, but let me show you what might be the easiest way to understand. So I've just modeled the west zone, and what I'm doing here now is to say, actually I want to further model this west zone. So I'm taking this as a first input and saying, okay, this is my domain that I want to subdomain, and within here I want to have my demo andesite west function I want to use, and then everything above that threshold is going to be andesite. So lithology andesite, and then we'll move this one, and everything outside of this one. So remember that we're working on the west zone only. So we have our lithology here, and yes, we want to have that as conglomerate. Okay, let's say OK. So as you can see, we're at the west zone. We've just created this fault zone here, and this just states that within the west zone we have an andesite part and a conglomerate part. Alright, so let's just build this one, and yep, we'll see there. We'll look at the results then. Okay, yes. Alright, so this one is now finished again, so let me turn off the previous one. Okay, now we can start looking at what we've built so far. So let's turn off the unknown, And let's turn off the function here. I think we can turn off the west fault here as well. There's a bit of an edge wobble, but that's alright. Let's turn off the air. So as you can see, we now have, let's turn off the topography as well, we don't really need it anymore. So we have the post-conglomerate andesite, we have the sandstone cover in this little area there, and then we have conglomerate here above the andesite and on the west fault. Alright, so we've nicely modeled this part now, but we still have more to do. So we have this remaining unknown part of our model here that we also need to start labeling. Let's do that now. Okay, so we move this one, don't really need it. So remember that we separated that one as well. So the eastern side with the fault. So let's include that one now. We don't need that one. We need the east fault sine function. All right, let me just cancel that one and just go to here. So as you can see, there's the red and the blue. So if you're careful, and what you can see is that maybe the fault should have been a little bit closer to this boundary here, but that's all right. For demonstration purposes, everything towards this east side can be considered andesite because this just continues all the way to the top. So if you turn on the topography, you can see that andesite sits all the way to the topography there. So everything on the east side of this fault within our model area we can label as andesite. This makes it a little bit easier because we don't actually need to specify a top domain. So in this case we can actually say, oh, we'll take the east fault function and we'll take everything oh no, it's actually above, so it's on the positive side, and we'll actually call that andesite. So now we've been modeling the andesite on the east side of our east fault as well. So I'll just model this again just so you have a visual reference. Okay, so that's done processing. Let's look at this. Alright, so now you can already see what's happened. So we have the green on this side, which is also oh, let me just turn on the legend. So you can see that we have andesite here on the east side, we have andesite on the west side of the northwest fault at the bottom, conglomerate in the middle, and we only have the central section which is labeled unknown, which we still have to model. So for this we go back here, so we don't need to specify any top level domain for this because we by default is going to be continuing it in the unknown domain, let's call it that. So for this we need our final function. So this is the central andesite function, and remember that andesite is at the bottom, and on the other side, so let's take the lithology here. So we need to actively click it and then select andesite, remove this here. If you don't remove it, this is gonna override the labeling that you're doing here, so that's why I'm removing it. And for this, the lithology, yes, we want to have everything on the other side as being conglomerate here, so we can say okay. So now we have andesite conglomerate here within the west zone, we have andesite on the eastern side of the function, so you can see the function here, and then we have andesite and conglomerate in this remaining area, the central area we still haven't done, and that will produce our final and complete model. So let's run this one and look at the results. Alright, that's already done. Now let's look at the result. And let's turn off everything else, so we don't need this one. So now we've got a faulted model, and let's take the settings here and remove the air. So yes, we still have our sandstone cover in this area. We have our post-conglomerate andesite, and we have, so we need to be a bit more patient, the conglomerate here. And as you can see, there's a nicely clear step for the faults on the east and on the west. We have a single unit of andesite left over. So we have a complete model with faults this way. We can also look at the way it's been modeled. So you see you've got a nice distribution of the tetrahedra, where you have very large tetrahedra in the bottom and very clear tetrahedra all the way at the edges. So this is the final model for geology, and yeah, you could now use this one for any type of other modeling. So if you wanted to do numeric modeling, numeric evaluation on these ones, we could actually use it. But as far as geological modeling goes, this is the end of this set of videos. Hope you enjoyed it, and yeah, keep in touch. Well, actually, I had a few additional remarks that might be useful. Look at regions like here. So notice that we have this whole section of where there's no data logged, and here as well. So in these cases, these sections are being ignored for any further modeling. So they're like empty spaces where there's no data. They get ignored for any further modeling. So it doesn't honor the drill sets, and that's what you're seeing here as well. Other places, there could be some additional settings that we could use to make it honor the data a little bit better. As you can see here as well, this drill hole hasn't been included in our fault, so we could probably go back and modify these things and make them a bit more accurate. I haven't really paid attention to that in this set of models. It's more about this one has been more about the workflow of setting up faulted zones and then modeling within each fault zone and then progressing to the next, and combining different areas where you have faults with areas where you don't have faults running through them. So although I haven't really specified it, only in the beginning a little bit. There's no fault running through this post-conglomerate andesite, and neither is there any faulting going on in the sandstone cover. So the way we've actually modeled, although you have your west surface actually extending all the way through it, these zones are not affected by this fault at all. So only, well, we actually used a different one, or this one. Yeah, so only where we've wanted to use those faults, or actually wanted to use offsets for the faulting, those units have been offset, not the other ones. Alright, that's pretty much what I wanted to add. Bye for now.